Hey, this is Josh. Thanks for watching this video. I think this is a good one because it's the part 2 to writing proportions. Just kind of takes it to the next level. And yes, it does get more complicated, but I wanted to make this video because I felt like it would be helpful to explain some of the complications that I see my students go through. And by drawing these out, I think this will kind of shed some light on what's going on. Oh, that's an awful line. Let's redo this. All right, let's see here. Let me try a little bit better. I guess that's a little bit better. Okay, I'm just gonna make this triangle, and then I'm gonna make like a little triangle here, or it's like a little bit smaller. Okay, a lot of times they'll start off with things like this. It'll tell you that it's a right triangle, so you know what's going on. And you need that information to know that these, or it'll say, you know, these two triangles are similar, or these two shapes are similar, so that you know that there's a relationship between the two. If you don't know that information, then there's no way for you to get an answer. And then it usually starts off kind of matching these guys up, okay? So if we have this guy being 10, a length of 10 feet, meters, whatever, miles, okay? And we say this guy is 5. And then we say this guy down here is 3. So what is this guy? Okay. Now, I always recommend redrawing the picture just because I think that it helps. This is a lot like the scale factor problems. And when it comes to doing these, there's 2 ways you can do it. You can put your box up here and do the magic number way, which I think is very helpful. We know this is the smaller of the 2 triangles. And so because we need to get the numbers to become bigger, we know this is the side we would multiply something with. Okay, if we're going the other way, we would divide. So 5 times something is gonna get me to 10. 2, good. 5 times 2 is gonna get me to 10. Now, because the triangles are similar, we know that we can apply this rule to these bottom lengths as well. So if 5 times 2 is 10, then 3 times 2 is 6, correct. Now, yes, you could look at this and I don't want you sitting there saying, oh my gosh, dude, you could totally just like 5 times 2 is 10. Like I can see that number relationship already. Therefore, how hard is it for me just to double that number? Yes, okay. But I want to teach the basics so that if this is 5.49 and this is 62.83, you're gonna be able to get that number. And on a side note, if you do have these wonky numbers like that and it doesn't completely go in, then you can just say your answer is about, and then write your answer. Because a squiggly equal or a wavy equal sign means it's about this, or it's approximately this. And usually when you're given square roots in there or decimals, this is more of what your answer is gonna be, okay? So now, let me redraw this because I see this happen a lot. Let's see if I can draw this thing. All right, oops, like that, okay? So it looks all crazy, and they'll tell you that that's a right angle and that's a right angle. And maybe they'll say, you know, this length here is 20 and this length is 8, let's say. And then they'll say this length over here is 2. And so tell me this guy right here, okay? They'll tell you that the 2 shapes are similar, which means we can bust this thing apart. And again, this is when I recommend redrawing it if you can, because I think that it helps you see things in a different way. So let me do that. I'm gonna take this guy and just kind of like turn it and then drop it right over here. I gotta make sure I write the values in the right place on this triangle. So if it helps you to redraw this right triangle 90-degree sign here, do it, because that's gonna remind you, oh yeah, this number is close to that on the shortest side. So therefore, if I turn it and drop it down, the 8's gonna go down here. The 20 is gonna be on the hypotenuse, which, by the way, is the longest side of a right triangle. If you didn't know that, now you do. So I've drawn that in on the hypotenuse, and then I can do the same thing. I can kind of bring this guy down as well. And lo and behold, we have the same thing as we had before, okay? So that makes it kind of nice, because I think that rather than seeing this crazy shape, and I do these in class to try to trip them up, I'll like turn it this way on some weird angle, and they're looking at it going, oh, how am I gonna solve this thing? And then I say, no, just take a second, break them apart, okay? And now when they look at it this way, they say, oh my gosh, like that's an easy way to solve this thing. You can either write it like I did with the arrows and use the scale factor magic number method, or you could write it as a proportion. And when you do those, you just need to make sure you match up your parts, okay? So if I'm gonna write hypotenuse over short side, 20 over 8, I need to make sure I write hypotenuse over short side on the other side of this equation. Again, if you flip-flop one of these, you're gonna get some crazy, wacky answer. And then, if you watch the other video, or if you're just getting better at solving these proportions, you can cross-multiply to get your answer. You could reduce the fraction and then cross-multiply. A couple different ways to do it. I'm all for the cross-multiplying because it's quick for me, I'm good at it, and I use it. But whatever method works for you, I encourage students to just use whatever is going to work. Go for it from this point on, but make sure that you match this guy to this guy, just like this guy to this guy. And I mean, these two on the numerator side are on the top, and then these two down below, okay? Let's go on to the next one here. I'm hoping that you're seeing that these are not that complicated. It's really just a matter of how you read the problem, okay? Let's do this guy. Okay. Oh gosh, I gotta work on drawing my shapes. Let's see here. And then we got another triangle here. So we actually have two triangles here. I got this guy over here is 20 meters, we'll say. That length we don't know. This guy here is 13 meters. And then the whole length is 21 meters. Okay, I got my right triangles, and then they labeled it like A, B, C, D, and blah, blah, blah. Okay, I'm not gonna do that right now. Because what I wanna do first is I wanna talk about the shape, okay? It looks kind of crazy, right? Like, how am I supposed to figure out this length? Now, if you've been doing Pythagorean theorem, yeah, you can use that on these as well, okay? But I wanna stick to proportions because that's what this lesson is about. So I can redraw this. Sometimes that helps, sometimes it doesn't. I'm gonna redraw it just so that you can see what I'm thinking, okay? So I'm gonna take this small triangle right here, and I'm gonna draw that guy just like off to the side, like right here, okay? I gotta make sure I use the same values, 13 and 20. And then I'm gonna redraw Big Daddy over here, this guy. I'm gonna redraw it right there, okay? Now your picture, that's awful. Your picture doesn't have to be that great, but you know, good enough so that you know what you're talking about, right? These are my right triangles. Let's see here. So now the length of this guy is 20, and then I got this extra length here, right? So I don't know how long it is actually. I know that it's 20 plus a certain amount, so I'll just write it over here like that. 20 plus x. 20 plus x. And then my full base here, they gave me the number, 21, okay? So I'm gonna use this side over here and complete the math. Couple different ways to do it. I can go for my magic number theory and try to get that number. If it doesn't come out perfectly, okay, because now I'm thinking, well, 13 times what gets me to 21? Pff, I don't know. I could start just using a calculator and going like, how about 2? How about 2.3? How about 2.4? Okay. Maybe it's easier to go this direction, okay? Meaning you would be dividing, because 21 divided by something is going to get you to 13. And if you're not sure, you could probably grab your calculator and say, well, what is 21 divided by 13? Oh, it's this crazy decimal number. It's like 1.6153, blah, blah, blah. It's a whole big crazy number, okay? So yeah, we know it's about 1.6, about, remember, wavy equal sign, 1.6. It's not pretty, okay? So this could be a method, but it's getting kind of crazy, and then you got this variable in there as well. Now it's starting to get really crazy, okay? So if this route seems a little bit wild, let's just stick to the basics, right? Compare hypotenuse to hypotenuse, bottom to bottom, and let's do that. Let's see here. So we have 20 is to 13 as 20 plus x is to 21, okay? And from here, we just work on it like anything else. Just because there's a 20 plus the amount doesn't mean that we can't use the methods that we already learned. It gets a little bit crazy. You just got to keep your math in order. 21 times 20, I don't know. So let's do it in a calculator. 420, all right? So we have 420 equals, now this is 13 times 20 plus x, okay? You've got to distribute the 13 equally to both. So I always draw these rainbows to remind me what's going to happen. 13 times x is 13 x's, and 13 times 20 is 260. Running out of space. I did the x first. Does it matter which one you put first? It doesn't. It's just a habit of mine to write the one that has the x first, because I know I'm going to be getting rid of this guy, and so it just looks a little cleaner as well. Okay, so I distributed my 13. I multiplied these two together, right? This is a quantity, so I had to do it in that fashion. I now have 420 equals 13x plus 260. I got to isolate the variable first. So let me subtract 260. And what you do to one side, I hope you're saying it. I really hope you are, because if you're saying you do to the other, you're getting into these math modes, okay? You're setting yourself up for success. 420 minus 260 is 160. All right, so I have 160 equals 13x. If you've gotten this far, we need to isolate the variable now down to just one unit. We know this is 13 times x, so we do the opposite. We divide by 13. What you do to one side, you gotta do to the other, and it's a fraction. Read it down. I draw these arrows every single time. You know, I think it's worth it. I really do. I think that you're going to get a lot out of using these basic rules every single time. Showing your work, writing the arrows, okay? Circling these to remind yourself what needs to be done. We read our fraction down. 160 divided by 13 is 12.3, and then it kind of goes on forever, okay? So x equals 12.3, and I guess it isn't exact because it's a long decimal, so you can make this wavy equal sign, so it's about 12.3, okay? And the question isn't necessarily asking, well, how long is this segment right here? They're usually asking how long is this whole length of this side. Oh man, this is getting crazy messy now. You know, how long is that whole length, okay? Or how long is this whole length right here, okay? Because we know this is to this as this is to this. So what is that length? Well, it's 20 plus x. If x is about 12.3, about 12, we'll say, we can just insert it right there. 20 plus 12 is like 32. I was saying it's like because, you know, I know there's more decimal stuff. I mean, you could say 0.3 if you want. You know, it goes on for forever, it looks like, or longer than my calculator can show me. And so now we have all of our values, okay? We have 20 is to 32.3 as 13 is to 21. So earlier I did get that, you know, approximate value of 1.6. So let's just see if it works. We know that 13 times 1.6 gets me to about 21. It's 20.8, but we know what we're trying to do. We're trying to figure out this magic number, the scale factor, call it what you want. So 13 times 1.6 gets me to 20.8 or about 21. Let's see here, 20 times 1.6 gets me to 32. So I'm pretty darn close. My numbers aren't exact, but I did get an answer that's very, very close, okay? And so just be careful, okay? Sometimes the problem will say, what is the length of X? And you just write your answer because you got it right here. And then sometimes it'll say, what is the total length of that side of the triangle? And I don't want you to lose points because you go, oh my gosh, I did all this work and I got to here and it's not even right. Just remember, you need to plug that value in to this length so that you can then get the actual total length of this thing. And then as the last reminder, write your units in. I know I didn't use them because I was teaching this, but if it's meters, do meters, feet, do feet. Like, make sure you write those because there's teachers that will take off like a quarter point. I have been known to do it too, you know, because I want to make sure that if it's all in meters, then your answer should be in meters as well, okay? Just so that you're keeping the same unit rates, okay? So thanks for watching this second part. I think that was hopefully helpful, especially when it comes to these guys where there's this extra part. Remember, there's not a lot extra to it. You just got to be careful and follow your rules of math. Thanks again for watching.